in the previous videos, we derived labor demand curves from MPL curves, marginal product of labor, right? And we put two labor demand curves, one for cloth, one for food, together to find the optimal allocation of labor between these two sectors. Now here in this video, we're going to offer a simpler version of the answer, okay? And we're going to rely a little bit upon math and also the graph, okay? Now, in the previous video, we already mentioned that marginal product of labor times the price of the product they're producing would be equal to the nominal wage, right? And this is true for both sectors, okay? And remember here, we're solving for the optimal allocation of labor between the two sectors. And from the previous discussions, we already knew that for this optimal allocation of labor, it has to be an equilibrium between the two sectors in terms of the amount of labor employed. By that, we actually mean the wage between the two sectors got to be equal, okay? Otherwise, we know the labor or the workers are gonna leave the sector which offers a lower wage and join the sector which offers a higher wage, okay? And this movement would continue until the wage rates between the two sectors are exactly equal, all right? So here, that's why we put another letter W here, the red one. That simply means it's a market wage rate, okay? In other words, it's going to be the same between the two sectors, all right? So once we get here, then we will be able to, make the left-hand sides of the two equations equal to each other, okay? So MPLC times PC equals MPLL times PF, MPLF times PF equals W, okay? Once again, W is a market wage, okay? Here is one more thing I want to remind you guys, which I forgot to do in the previous video, I believe. And here for this equation, some of you probably feel, quite familiar, like in somewhere you saw this before. Yes, you did. This is what we discussed in intermediate macroeconomics. And when we talk about the neoclassical model, this is what we derived over there. Once again, based upon the firm's profit maximization behaviors, okay? But in intermediate macroeconomics, it's more often, like we wrote this in a slightly different way. We said that it's MPL equals W over P. Remember that? So it's marginal product of labor equals real wage. Okay? So nominal wage divided by the price, that's going to give us the real wage. Okay? And we said that the economic intuition behind this equation is your contribution to production, which is measured by MPL, equals how much you get paid, which is measured by the real wage, W over P, right? So this is exactly the same equation. We just write it in a slightly different way. We move the price to the left-hand side. That's it. Okay? And again, the economic intuition changed as a result. So the left-hand side becomes the benefit of hiring this unit of labor, okay? The benefit for the company or the employers. And on the right-hand side, that's the cost, okay? That's how much the company has to pay to this unit of labor, okay? So when the company maximizes its profit, again, these two are equal, right? Now here, once we get this equation, let's come back here and do a little math transformation, okay? What we want to do is basically we want to put marginal product of labor on the same side of the equation and put the prices on the other side of the equation, okay? So what we're going to do here is we're going to move MPLC to the right-hand side, and we move PF, which is the price of food, to the left-hand side. So you can forget about the wage, this thing, okay? Because the wage is just the bridge, okay? Which, you know, helps us build the connection between these two, okay? All right, how we're gonna move these? One way you can understand this is we could divide both sides of the equation by MPLC. So here on the left-hand side, this guy gets canceled out. On the right-hand side, you find MPLF divided by MPLC. Similarly, we can divide both sides of the equation by price of food, PF. So on the right-hand side, it gets canceled out. On the left-hand side, you see PC over PF, okay? Now here, we flip the two sides, and this is what we get, okay? Again, MPLF divided by MPLC equals PC divided by PF, okay? Price of cloth divided by price of food. Another strange thing you find is here we add the minus sign to both sides of this equation. Okay, why we want to do that? All right. Now, the answer is once we add the minus sign here in front of this ratio of marginal product of labor between food and cloth, the whole thing here on the left-hand side is the slope of PPF curve, okay? Again, the left-hand side becomes the slope of the PPF curve. So here we know eventually that the slope of the PPF equals minus the ratio of two prices, okay? Price of cloth divided by price of food, okay? Once again, this is optimal. At this point, we see the optimal allocation of labor between the two sectors. Now, let's see what this means on the graph. Okay, we put on the PPF graph here. So basically, we see that, you know, at point 1 here, if it is an optimal point of production, okay, then we're gonna see that at this point, the slope of the PPF, which is also the slope of this tangent line, is just going to be equal to minus the relative price between cloth and food, okay? Now here, let's take a step further and explain why this minus, you know, the relative marginal product of labor between food and cloth is just the slope of the PPF curve, okay? I believe in your intro or intermediate micro class, you should already learn this. But again, just in case you already put it behind, so let's briefly talk about this, okay? Now here we revisit this four-quadrant diagram, okay? But actually, we're just gonna focus upon this upper right or first quadrant, Okay. Now, once again, we just want to show you why this guy here on the left-hand side is just the slope of the PPF. Okay. Now, suppose this economy is moving from point 1 to point 2. Okay. Suppose it's moving, then we know that the slope of the PPF between 1 and 2 is just going to be like this. Okay. This red tangent line. Okay. The slope. Now, what we need to do is we're gonna, move this red line a little bit towards the left so that it passes through point A and point 1 and point 2. All right. In other words, here what you see is this red and the orange lines are parallel. Okay, we just move this red one a little bit towards the left so that it's not going to be a tangent anymore. Instead, it passes through 1 and 2. Okay, now we do this because it's easier for us to figure out this ratio or the slope itself. Okay, now from here we should be able to see that this vertical distance or the vertical distance is just going to be the marginal product of labor in food. Because remember, when we move from 1 to 2 here, this is how much units of food we are going to give up, right? Now, remember, from 1 to 2, because labor is moving from out of the food sector and into the cloth sector, so we produce more cloth but less food. So suppose this movement from 1 to 2 is teeny tiny, okay, because that's how we figure out the slope, and then this vertical distance would be quite small as well. So that's marginal product of labor in food. Okay. Now, the horizontal axis here, from this point all the way here to point 2, would just be marginal product of labor in cloth. Okay. Again, similarly, when we move this from 1 to 2, we got more labor joining the cloth production. So this is how much more cloth we can produce because of that teeny tiny movement of labor. Okay, between the two sectors. Now from here you would be able to see that the slope of this orange line is just going to be MPLF divided by MPLC. Okay, so that's graphically or mathematically, that's how we define the slope of this orange line, right? Straight line. Okay, now because it's downward sloping, so we have to have this minus sign in front of it. All right, that's why we lead it, this minus sign. Okay, so this here we use a graphical way to prove that this is just exactly the slope of the PPF. Okay, which again it's measured by this red line here. But because these two are parallel, so their slope should be equal, right? Or another way you can understand why we add this minus sign in front of it is, remember here when we move from 1 to 2, then we're actually losing food, right? We're giving up food to gain cloth. So MPLC here, it should be positive, right? Because we gain more. But MPLF here, we have to add a minus sign in front of it because we're losing it, okay? Now here, the simplified version of the answer is at the optimal production point, the PPF must be tangent to a line whose slope is minus the relative price of cloth to food. Again, we already discussed this before, right? And so this point, suppose it's optimal, then the slope should just be equal to this. In other words, if you pick other points along the PPF, the slope should not be equal to this. So this is, we should only find one point on the PPF like this.